how to analyze linear motion using Kinovea. So you go File and Open. So you choose a video. I'm choosing this one. I shot using my iPhone 5 at 30 frames per second. I push Start, and I see that it begins to move about there. So I move back my slider. Now select my working zone, so it's always going to start from the same place. First thing I need to do is I need to go up to Image and select the coordinate system. If I select something like that, we see that he moves from here up to here, and so it's not entirely in the x-plane, which is a bit of a problem, but that's okay. I'm going to get a ruler. I know the person's 1.8 meters tall. It'd be better to have a ruler actually in the picture, but in this case we didn't have that, so I'm going to put in 1.8, and I'm going to change the units from centimeters to meters, and then everything in our video will be in meters, and that'll be good. I'm going to add a stopwatch. I'm going to right click and go configuration. I'm going to make the stopwatch nice and big so that we can read it. Could add a label, especially if you're going to have multiple stopwatches, that's really handy. And I'm going to click play, and we see about there he starts to move. I'm going to go back one frame. I'm going to right click on this and I'm going to start stopwatch. I'm also going to go right click on that measurement, and I'm going to say it can hang around for 100 frames, just so it's nice and easy. And so we see that person moves, step by step, jumps on, and we can say probably stops about there, so I can go stop stopwatch. I can then add a length from where he started, where he ends, to about there. If we go back to the start, play. Actually, sorry, my mistake. I need to right click on that line and go always visible. You don't have to make it always visible, but for the sake of this, it makes it a bit easier. I go back to the start and I click play. I probably could just move this line up a little bit. So we now have a timer, we now have a distance, so you can work out linear velocity if you use kinematic equations. I'm now going to right click. I'm going to click on the stopwatch and add another stopwatch, make it a bit bigger. And it's about here where I click start, but it's about here that it begins to rotate. And so you can let the video finish and figure out all the calculations you need to figure out. I'm interested in the linear bit at the start. If I push start, there we go. I'm going to track something on here. So I'm going to right click and go track path. This is going to be a little bit painstaking because it appears it's not a nice little dot. So a post-it note on your arm or a bit that doesn't really move so much. It's quite helpful. So this will automatically track stuff. Where it doesn't, you can go frame by frame and move it. And so you see that there's a change in height there as the person begins to go airborne a little bit. So that last frame was a bit strange. So back one, we'll bring this one back up. The smoothness of this line now will dictate the smoothness of your data later. So it's pretty important to get this tracking right. As we painstakingly go through each of these. So you can see he's beginning to accelerate a little bit, which is what you'd kind of expect. Most of the motion's in the x direction, but because the video is not purely taken in the x direction, it's a little bit confusing. Take it with a little bit of grain of salt. Jumps on. If you've got a distinct object in the video rather than just a big black blob, this is much easier. There we go. And we right click and go end path. We can click this one to go back to the start again. Watch it all over again. So there we go, the lovely blue line. Boom. What we do now is we go File, Export to Spreadsheet. You click the Microsoft Excel one. It's been called that. I then open up this one and I right click and go Open with in Excel. I choose the Excel file which I've been given, and I open that one up as well. And so this is the Excel spreadsheet that Kinovea gave me. 1.63 seconds, I go right click copy. I go to the other Excel spreadsheet and I copy and paste it, X, Y, and T. And I just go paste. And then all of a sudden there's angle stuff. And the angle stuff shouldn't really make sense because it's not in the angle, and so you'll have to go through and understand that an angular displacement curve doesn't really make sense, but a linear distance time graph should make sense. And so that's the one we're looking at, because it's not going around the circle, it's just going in a nice straight line. We see it's a little bit curved. I can right click and go add a trend line, display equation on the chart. You can see that the time at the bottom doesn't really make sense. We didn't go for 50 seconds. If you right click and go select data, and I know there's 57 bits of data, so if I change this number to be the exact number of data points I've got, 57 data points, then you see that my axis actually works out fine. So my paste data here column, it goes up to number 57, and that now is 57. So in 1.6 seconds, we travelled 2.5 meters, which is 2.5 and a bit meters, which is more or less what we had discovered.